This is 6.2, number 29. All right, if you were to use vertical rectangles, you run into some problems, and it's not so bueno. It's doable. You will notice that your rectangles with verticals are kind of weird over here. It's not going to make a box for me. Okay. Because what will confuse you, your big Y and your small y are both the same function. So how would you do that? Technically, it's not a function. So I'll explain what's happening. This is the red graph. If you were to solve for y to get your big Y and small y, you would add 3 to both sides, and you would square root both sides. But once upon a time, a teacher told you you need to put plus or minus. And here's what's going on. You have a plus answer and you have a minus answer. So one of the answer comes out positive, one of the answer comes out negative for the same value of x. Well, that's what's going on here. So if you plug in a value of x, say this one, you get a positive and a negative. So technically what's happening, the top is x plus 3, and the bottom is opposite of x plus 3. So if you were doing vertical rectangles, your height would be big Y minus the bottom, which is little y. And so you could actually do that. But then you have another problem. So you'd have to find that point and get the area of here. But here it'd be the red minus the black, and you'd have to use this minus the equation, that black line. That's why you wouldn't want to do vertical rectangles here. So if this were an FRQ on an AP test, you would not want to choose verticals. That would get very ugly. Therefore, you'd want to use horizontal rectangles. And let me draw one for you. It didn't do it. Try it again. There we go. Let me shorten that up. So that is one of them. The first one would start down here. The first one, stop that. Bad computer. There's your first one, and you keep on going till you get to your last one up here. That would be your last one. So in order to figure this out, you need to know those 2 points. And how do you find those 2 points? So on your test, I would expect you to write this. 2y equals y squared minus 3. And I can't remember, I told you no calculator on this. So you would subtract 2y from both sides, and you get that. You would factor this and get that, set each equal to 0, and you get -1 and 3. So now you know a couple of things. Down here, the y coordinate is -1, and up here, did I write that down right? I did. The y coordinate would be 3. The x coordinate you could figure out by plugging those in, but I'm not going to do that right now because we don't need that. So on a test, I would give you 1 point for setting equal to each other, 1 point for solving that. Now we're on our way. I want to add up a bunch of rectangles, starting at -1, ending at 3. And so you got to see it's the y value here, which is -1, and the y value here is 3. You're adding up all the rectangles stacked up, starting at -1 to 3. I know some people struggle with seeing that. I don't know what to say to help you see that. And I don't want you to memorize. You should be able to see, yeah, first rectangle, second, starting at -1, and I stop at 3. It just makes sense. So keep processing until something clicks. Now, how wide is that rectangle? If you move up and down, does x change or y change? You should know y changes. So this up and down is a change in y. So that should be dy. And then here, I'll call that the length. That's going to be big X minus small x. Because when you want to find a length, you always take the bigger number minus the smaller number. You never go the opposite way. And which one's bigger, the black or the red graph? And again, on the xy axis, bigger numbers are to the right. So it's going to be black graph minus red graph. So the length will be black graph, 2y, minus red graph, y squared minus 3. And again, if you forget those parentheses, you will get it wrong. So it's going to be 2y, distribute that. It's going to be minus y squared plus 3. So here we go. The length of my rectangle is going to be 2y minus y squared plus 3. And the thickness or the width of the rectangle is going to be dy. And this will give me the area of the shaded region. Take the antiderivative, it'll be 2y squared over 2 minus y cubed over 3 plus 3y. Applying the fundamental theorem of calculus, I plug in 3. And then I plug in -1. And I start to simplify. This will give me 9 minus 9 plus 9. Really? That seems kind of weird. Minus, and that's going to give me 1 plus 1/3 minus 3. Well, those cancel. So I get 9 minus, and we can do some math. 1 minus 3 is -2. -2 plus 1/3 is -1 2/3, I think, which is plus, so 10 2/3. Hopefully, that's the right answer. I don't have the answer written down here, but let me go ahead and say that's right.